Today, I would like to walk you through setting up a temperature scan on your device under test while it is exposed to certain environmental conditions. To do so, we will use the Keithley DAQ6510 Graphical Data Acquisition and Multimeter System. The following slide provides the details of the setup. Let's establish our thermal profiling setup. With my terminals set to rear, I'm presented with the UI. Build a scan. Let's add a group of channels. For this test, I want to add channel 101, 110, 115, and 120. They're all going to measure temperature. I mentioned setting labels for each channel. Let's do that now. Channel 101 will monitor a regulator. Channel 110 will monitor a microprocessor. Channel 115 will monitor a transistor in the charge control circuit. And channel 120 will monitor the enclosure. I mentioned channel 110 is monitoring a micro. It has a tendency to get hot. Let's provide ourselves a notification if something goes wrong and we hit that condition. So I will establish a limit. I will set a high value of 28 degrees C. And then if my back is turned, I want to hear if the limit has exceeded. I accept. Now with all of my measurement settings applied, let's turn our attention to the scan setup. I want to set my count to iterate 1,000 times. I'll apply a scan interval of 1 second. You'll notice that my scan duration is updated to give me an approximate run time for the whole scan, 16 minutes and 39 seconds. During the scan, I wish to export the data after each scan to an external USB drive. I will accept all my file defaults. I'll take my USB drive and place it into the front of the DAQ6510. And should the power go off in that 16 minutes sometime early in the scan, I want it to restart from the very beginning without my intervention. So I will turn power loss restart on. Let's go ahead and start this scan. And we will view the scan status. You can see on the carousel, we're monitoring the last channel that was configured in our scan channel setup. Let's go ahead and look at each individual channel. .120 is still selected by default. I accept. Now you can see that the carousel is monitoring each of the 4 channels and letting us know by the label that we applied what measurement goes with what channel. You can also see in the measurement window here, as the instrument is taking measurements for each individual channel, that those are displayed in the main area. Let's observe what happens when we hit a limit condition. Here, you notice that we're told on the front panel what the condition is. The microprocessor is getting hot, and we hear the audible alarm. Let's stop the test and evaluate what's going on. Let's turn our attention to the graph, and I will set my scaling so that I see all my data. And we can see that the problem channel is the microprocessor. Let's turn our full attention to just that channel, and I will deselect all of the others. Let's zoom in to get a better feel of what's going on here. Let me apply cursors, just the verticals. And we can see that these vertical stats, or V-cursor stats, tell us that we have a min and max, topping out at 37.02 degrees, the average about 33.23. But our box is saying this is too hot. So what we can do is we can take a snapshot of this by pressing Home and Enter, save the image on the UI to our USB drive, remove it, and email it to a technician who can fix the problem.